हेलो एवरीवन। सो आज कैजुअली एक लीड कोड क्वेश्चन सॉल्व करेंगे। मिनिमम कॉस्ट टू कट स्टिक। ये प्रॉब्लम मैंने बहुत पहले एक बार सॉल्व किया, नॉट दिस वन बट सिमिलर टू दिस वन। तो इसमें बेसिकली काइंड ऑफ अ डीपी जहाँ बेसिकली वी विल ट्राई ऑल द पॉसिबल places where we can make the cut and then minimum one को we have to return. So let's try solving this one. So we will try to write a recursive solution और उसके बाद try करेंगे if we can make change it to iterative one. So let's have a function. Let memory help us for now and तो अगर लेफ्ट एज greater than equal to right, we can simply return 0. So basically हम क्या करेंगे कि so इस एग्जाम्पल से देखते हैं। सो इनपुट इज लाइक 1345, तो हम लोग कट लगा सकते हैं 1345 पे। ओके, सो वी विल ट्राई all the possibilities, like we will try to cut at 1, then at 3, then at 4, at 5. तो इसके लिए हमें कैसे करना पड़ेगा कि for int I equal to left I तो किसी भी पॉइंट पे if we make a cut, तो basically if we make the cut, the cost for making that cut is the length of the stick. तो जैसे let's say this is the full stick and if we decide to make a cut at 3, so the cost would be the length of the stick at that time, so it is 3. तो जैसे तो इसको निकालने का तरीका क्या करेगा कि उस समय का जो भी लेफ्ट है हमारा, उसके पीछे वाला इंडेक्स और जो भी राइट है हमारा उसके बाद वाला इंडेक्स, that will be the give us the length, the difference between them. So basically so in that case अभी मेरा आई लेफ्ट पे है, तो let's say so the cost would be I think max value in Java, right? तो बेसिकली अगर हम कहीं भी कट लगा रहे हैं तो उस कट के समय लेंथ ऑफ द स्टिक होगा basically all cuts left -1. So basically let's say अभी 3 पे लगा रहे हैं, left would be 1, right? So left minus 1 would be 0 and right plus 1. So right plus 1 minus all cuts left minus 1. तो ये तो cost हो गया, plus up basically it's kind of a partition which has been created. So let's say we made a cut at 3, so now this is the partition. Now along with this there would be helper or cuts. Index is not required. Now left partition, left would remain as it is and right would become I, at I we made the cut, so left will become I minus 1, right? I minus 1, fine. Helper cuts. Now this would be I plus 1 and right, fine. Right. So left and right, two things. Okay, let's first see this one, then we will try to use some 2D array for memorization. Return answer. Okay, so yeah, now let's define. So basically in the question we are giving 3 5 1 4 where we can make the cuts, right? But they have not given 0 and 7 in the this array, cuts array. But if you see here, we are doing right plus 1 left minus 1. So the first case it will go beyond the index which we have. That's why what we will do, we will define a new array and cuts dot length plus 1. Okay, sorry, plus 2. We will just copy the data. So at 0th index in all cuts array we have to put 0 itself. So what we will do, all cuts, and we will start from I plus 1 equal to cuts I, okay? And at the end all cuts equal to n. So basically at the end we have to append n. And anyway we have to sort it, so we could have appended everything at the beginning and then we could have done the sorting, but anyway. So 7 is the length, so 7 we have appended. Arrays dot sort. So you guys understood why we are sorting it, right? So basically this input itself is sorted, so not an issue. But let's say example where it is not sorted. In that case you can't just write these things, right? Because when you make the cut in these situations, when array is not sorted, you can't basically claim that you are able to partition the stack into two different parts, right? Because let's say if you are making a cut at 1, so you have 5 6 here, 4 2 here, so you are making the cut at 1, so you understood making a cut at 1, everything was on the right, but here from the array you will see that this part goes to the left part, this part goes to the right part, but that's not true, right? So that's why we have to sort the array. And now we can just call this particular function, so it will be all cuts. Left would be starting from 1. So remember guys, we have appended 1 0, so our actual value will start from 1, and right would be all cuts dot length -2, right? Because at the last we have appended, so we have to start from the second last element. Let's see if it runs, otherwise we have ChatGPT here to help us. Output 11, expected 16. Sum of the length of the before the total cost of the cuts. So in this case we are returning 11, but it should be 16. Let's see. If left greater than equal to right, we are returning 0. If left and right are equal, we may have to make a cut there, right? Let's try this one. Fine. Obviously I won't try to submit it, reason being, if you see the constraint, n is going till 10 to the power 6. But n doesn't matter, I mean the length of the cut matters, and length of cuts would be minimum of n minus 1 and 100, so it would go at most till 100. But still let's try to put memorization here. So what we will do, we will just define a 2D array. So how we will decide it, we have two moving pointers, right, left and right, based on which we can decide what would be the answer for that particular combination. So and left and right are starting from 1 and going till all cuts dot length -2. So for the saber file, let me just put it as n would become very large. N would become very large, but the thing is left and right are just indexes, right? So cuts dot length fine, and we have to pass this one dp of left right equal to answer, fine. And here we can check if dp of left right not equal to -1, sorry, not equal to 0, Let's see if it runs or not. Okay, we can try submitting it now. So this has worked fine. Now let me try. Okay, I mean, I will just start a new recording to convert into the iterative solution. Okay, then